Generative AI is really challenging the boundaries of computing environments. There are newer technologies coming that are designed just to support these kind of massive AI and computing capabilities. Vector database is one of them. In today's video, we will take a look at vector databases, what they are, look at some of the products, and understand some of the inner concepts behind them. I'm gonna use an article, a couple of articles basically from PineCone, and also use Google embedding project to talk about and see. And let's get started. Just a quick shout out, if you have not subscribed to my channel, please do. Starting off. So vector databases are a new kind of databases that are designed to store embeddings and dense vectors. Now, what are embeddings and dense vectors, you ask? Let's get started. So vector embeddings are, let's start by thinking around how databases work and behave, right? And then we'll go more deeper into the concepts of how vector embedding works, what is a vector, what is an embedding, they are the two words that we need to understand, how does an embedding model work, and so on and so forth. So the first thing, and I really found this article good, and that's why I'm using it as a base. So the first thing we need to understand is what problem are we trying to solve? If you look at traditional systems, right, you have data structures that are represented as objects and you keep on storing them in your databases. Now these have some properties, or you can think of them as columns in the databases, and that's what, usually fuels the application that, we are building. As time grows and matures, the number of column increases. And as most of you guys know, when you're working in a machine learning landscape, you really can't take the entirety of the column because that might not be something that you want to use. So a concept called feature engineering comes to mind, right? And that's what you do. So, but feature engineering is a construct when you're working with structured data, when you're working with, tabular data, when you have columns and stuff. But how do you work with unstructured data? What about it, right? How do you go on and, represent an unstructured data as a sequence of numbers? And that's the problem that started all of this conversation around vector embeddings, vectors, and databases. So the idea is that we use vector embeddings as a form of features, or as a form in which, text is converted into numbers where two information is captured. It captures the semantic information and it captures the values also. And what do we mean by that? We'll take a look further. So what are vector embeddings? If we go back to our physics or math classes, a vector is a mathematical data structure, right? I hat, j hat, k hat, right? These are the three different vectors in three different dimensions. But we know in ML and AI and in maths, there's multiple dimensions. We just can't visualize them, right? So a vector can be, of multiple dimensions. But there are two essential characteristics of a vector, right? It's a mathematical structure that has a size or direction. So you can think of it as an arrow. Now, if we think in XYZ space, like a three-dimensional space, it could be 0, 0, 0 starting point, or it could be 1, 1, 1, or whatsoever. Now, if you think about that, it's very intuitive to think of vectors as simple arrays, right? So you have, a vector represented as 0, -2, and 4 in this. Now, what happens when you represent multiple vectors in a space, right? It's natural to think, and if you imagine a three-dimensional space, it's natural to think that, some points would be closer to one another and some would be far apart. Now, these are what typically start, these are what, these are the conversations which give a vector the notion of similarities, right? And we measure them using cosine similarities. How do we do that? We'll take a look now. So there's some description of, this content. I'll probably put this links in the description of the video for you to walk through. Let's take a look at, now that we have looked at what a vector embedding is, let's try and understand a little more deeper. Now, an embedding is just a representation, right? But what we want is we want to have a more deeper understanding of it. Let's say we want to have a large data set. Given a large data set, we want to have an understanding of what words or what sentences are closer to another. Can we do, linear algebra, like, king minus man plus or female plus king is equal to queen or something like that, right? These are some of the generic examples. So there are deeper machine learning models, something like a word2vec or glove, which are widely used for a wide variety of machine learning and NLP tasks, to be specific. Now what I'm going to do is I'm going to hop on to a TensorFlow projector, which is this link over here. And what this does is this has a 10k vector word2vec 10k database, and the data has been converted into 3 principal components on this side, and you can play around with it. This is a very popular website and it's kind of cool and fun to watch too, right? We can put certain gradients, you can change some parameters, you can actually take a larger vector database as well, but I think for the sake of this conversation I'm going to stick to it. You can go here and you can search for something like a queen, right? Now let's do a click on queen. Now if you see what's happening is, as I gave the word queen, it's taking cosine similarity and it's giving me the nearest point in the original space is Elizabeth, and that's what is bold, right? Queen and Elizabeth. Now how does it know Elizabeth was a queen? So now this is the power of a vector embedding and an embedding model. The model kind of using the location and the direction first identifies what's the plane and then looks at the distance between them. Now if you see, there are some words which are further away. I don't know why this is not scrolling, but if you look at something like a monarch, it's still related but further away. King is close, Anne might be another queen, and you see Princess, Catherine, Victoria, Scotland. Lot of related keywords in that space which should be related to queen. Now if we take a look at gun, let's take a look at gun, right? So you see all the relevant information around guns. So there's gun, pistol, weapon, firearms, machine, cannon, rifle. All of these are different kinds of weapons that are very closely associated with the concept of a gun, right? You can pretty much do a lot of words findings like this, sentence finding like this. Let's say, science, and you see science fiction, science philosophy, sciences, technology, physics, mathematics, and all of these are different sciences, right? So in a nutshell, what we are trying to understand here is that this embedding, right, this model which constitutes of a lot of information about this vector2k database is a machine learning model which understands the semantic relationship between words. I will repeat. This is a machine learning model of a given text where the words are represented as numbers and the physical space gives a notion of the similarity or direction and the closeness or distance between them. So it has semantic understanding, which means it understands not just what the word is, it also understands the context awareness. So that's what is a vector embedding. That's what is represented in this article. So if you think about it, what I just said, raw data given to an embedding model, you get a vector embedding, right? Some questions, what do you do with vector embedding? I think it's very, very simple to imagine that. You can build search engines which traditionally work by searching of overlap of keywords. If you add, adding a layer of vector embeddings, your search can go a little more powerful, and it can give more semantic meaning. It can give meaning basis the semantics rather than just counting the number of words. There are more primitive models than this. I think bag of words, etc. is one good example. There's other embeddings as well, like glove, etc. But word2vec is quite popular. You can build question answering applications. Image search is another great tool where vector embeddings are very nicely suited to serve on a basis for image retrieval tasks. You can apply the same concept in audio, because everywhere where you can represent something in numbers and make a model out of it and figure out what is the contextual awareness of this in a given space. Now the projection was in a 3-dimensional space because we did a reduction using PCA into a 3-dimensional space, but you can technically, these are very dense vectors and very multi-dimensional. There can be recommender system and anomalies as well, right? Now let's come back to our original conversation, right? Vector database. Right? We just learned that embeddings are generated by AI models. something like a word to glove, but they are also generated by large language models like ChatGPT and stuff. And there are a much larger number of attributes or feature for an LLM, right? So there are some technologies that are present that can help quicken the search. Basically, this becomes a search problem, right? One such technology which Facebook research released out is called I think vector index. So there's a product called FAISS, and it's a library that can help for similarity searching and clustering of dense vectors. This is different from a vector database, but a very similar concept. So you'll hear a lot of vector indexes conversations also, and vector databases also. Now, why is this not sufficient? This is a library and index. This is not a full-blown database product, right? This is good, but this is not completely solving the need for a database. So why was there a need for a database? Because there's inherently large number of vectors coming out and being pushed, right? You just don't want an indexer, you actually want a place to store this, and traditional databases are not good at it. They are not designed to to deal with this kind of data, and these kind of databases will be typically supporting searches powered over by large CPUs and GPUs. PineCone is a product, and there's tons of different database products out there that do this. This video is not sponsored by PineCone or anything like that. So there's a need for having a specialized databases like PineCone, and we'll talk about that further. Now, so how does a vector database work, right? This is a good representation, and that's why I really like the infographics in these articles. That's why I took it. So you have, we talked about a content which was vector 2K. We gave it an embedding model. We looked at this part, and we had an embedding. Now this embedding can either be loaded into memory, but for large language models or for building applications, we would rather have a database. That's where a database comes in. So first we use an embedding model to create a vector embedding for the content we want to index. So what's happening is a large language model is already existing, but let's say we want to add context on top of that, right? So we have some information already stored, and we took our context, we put it into an embedding model, we put it through we got an embedding, and we stored it in a vector database. Now what happens is, when you have an application query coming in through a chatbot or something, you run it through the same embedding model, get the embedding, and bounce off against the vector database. So the existing knowledge base, which is much larger knowledge base, and your query coming in, it quickly looks up, right? It's a lookup conversation. So you have multiple, it's a database, right? So you have multiple vector embeddings. You have a lot of data available which has been converted into an embedding, and a small search is coming, something like the same thing which I was doing, queen, but at a much larger scale, like who's the queen for England, or who was the last queen of England, right? And that's some kind of an information. That's the kind of a question you would ask ChatGPT, right? So that's what is a vector database. Now what's the difference between a vector index and database? I think I was just talking of FAISS, right? So there's large there's the indexes can definitely significantly improve the search and retrieval, but they lack the core capabilities around a database, something like metadata filtering, data management, ability to scale, updation, backup, ecosystem integration, tons of different tooling around it. And how does this database work? Let's take a look at it. So you have a simple pipeline for a vector database. You have vectors, index them, give it to a database, ready for querying, and then post processing. So the vector databases does indexing using different algorithms, and you can select what kind of algorithm you would want. And this step effectively maps the vectors to the data structure, right? To basically the kind of input data you had. The querying capability is basically built on top of that index. So a query would come, hit the database, look up the index, and you will get a retrieval. And the post processing, right? In some cases, you just don't want a simple answer. You probably want multiple answers. You want ranking, re-ranking, and stuff like that. So these are some of the things that a vector databases does. different algorithms. I'm not going to go into the depth of how these algorithms works. You can check them out as to what's the different algorithms that a vector databases uses. There's random projection, project quantization, and there's one more, yeah, locality sensitive hashing. These are some three different kind of ways which or at least three from a pinecone perspective that they use. And that's probably it about vector databases. One thing which I'll want to mention is that there's a race going on in vector database. There's a lot of different vector databases. There's Chroma, Pinecone, VV8, FAS. Microsoft is also doing something in this space. I don't really know the name of their vector database that they have, but they are doing a lot of experiments in this space. So that's what is a vector database, and that's what I wanted to talk about. So thank you for watching this video. Have a nice day.